Hello everyone, in this video we will be going over iterative statements in C++. We'll see what loops or iterative statements are, we'll see the different types of loops in C++, and also we'll see them in action in code. So while programming, there may be situations where we need to execute a block of code several number of times, and loops or iterative statements allow us to execute a statement or a group of statements multiple times. And to allow us the control over the execution, there are also statements called as loop control statements, using which we can change the execution from its normal sequence. The different types of loops in C++ are for loop, while loop, do while loop, and nested loops. The different loop control statements are break, continue, and go to. So the break statement is used to come out of the loop entirely. The continue statement is used to skip to the next iteration of the loop. So it does not come out of the loop entirely, but if the control comes over the continue statement, it will not execute any other statements within the loop after the continue statement, and instead it will just skip on to the next iteration and begin execution from there. And then there is the go to statement. Here it will transfer the control to another label statement, although you will not see go to being used as widely or as commonly. Now let's take a look at them in code. Right. So here, let's first start with a question wherein we are asked to print the first 10 natural numbers. So if we do not know anything about iterations or loops, this would be a very naive solution to our problem, wherein we just print out all the first 10 natural numbers one by one onto the console. But what happens if we are asked to print the first 100 natural numbers, or 1000 natural numbers, or 10,000 natural numbers? So this solution is not very scalable. We cannot sit down and write 10,000 times the same statement in order to achieve our goal. So this is one of the examples where loops or iterations can actually help us. So let's see how to solve the same problem using the three different types of loops which were discussed before. So we're using the for loop, the while loop, and the do while loop. So this is an example of a for loop. This would be the syntax for a for loop, wherein we have the for keyword, and within brackets we take three expressions: expression 1, expression 2, expression 3, and then there'll be a block of code. And depending upon these conditions, the block of code will be executed for a certain number of times. So typically what we call expression 1 is the initialization block. Expression 2 would be the condition which will be checked each time to see if we want to execute these block of statements again or not. And expression 3 is used to modify or update certain variables or parameters which we control, which help us to control the number of times these block of statements are executed. So this would be one example wherein we actually take in three statements, and then we print out each time a natural number. Let's see how it works. So in the initialization block, what I'm doing is that I'm defining a variable I and initializing it to 1. So here int I equal to 1 is declared within for it to be used within these curly braces. So in our case, I becomes the looping element or the iterative element which we will control and which will control the iterations for us. Next, there is the condition which is to be checked each time to see if we should continue with executing the code block or should we come out of the loop. So what I'm doing here is this function takes in an integer n as an input. So depending on n, we'll see if we want to print or not. So what I'm doing here is initially I'll initialize I with 1, so I equal to 1. Then the condition is as long as I is less than n, less than or equal to n, keep on printing I. And the moment I becomes greater than n, this condition will fail and I do not want it to be printed anymore. And that is when the control will come out of this entire block. Third statement is the modification or the update statements, wherein I'm increasing the value of I by 1 so that it can continue executing and it can continue to print the next natural number. So how the code execution will actually go is, initially when the control comes to the for block, it will evaluate expression 1, following which it will evaluate expression 2. Expression 2 is our condition for the loop. Condition for the loop. Then it will go on to perform the block of statements. Statements. I can't seem to pronounce today. So it'll go on to perform the block of statements, after which it'll come to expression 3 to modify a loop variable. And once it is done with modifying the loop variable, the control will go back again to expression 2, which is the condition for the for loop, to check if it needs to execute the block of code again or not. So how it will go, how the control will flow is, it'll first initialize the value to 1. It'll check this condition. If the condition is true, it'll execute the statement. After executing the statement, it'll come back to modifying the variable, and then it'll check the statement again. If the condition is still true, it'll again execute the block of statements, modify the value, and check the condition again. This goes on till the condition is false. So let's see that in action, how it varies. So hey, we do print using for. And since we want the first 10 natural numbers, we pass the input as 10. So we see first 10 natural numbers are being printed. What happens if I pass 1000? We see that it goes on to print 1000 natural numbers, which is way more convenient than having to write each natural number, each increasing natural number 1000 times. So that was for loop. Also, you can also, one thing to keep in mind is, each of these statements is not necessary. Okay, the condition is of course necessary, but it need not be the same as being shown in this example. For example, I can also always have a for statement of this nature, or rather this nature as well. So each of these expressions need not actually do what we have generalized them to be. So expression 1 is generalized and considered to be used for initialization. Expression 2 is always the loop condition, but we need not actually provide any specific statements over there for it to function as a loop. So let's see what happens if I do not provide any of the statements, and I try to conduct the loop, and let's see how the code behaves. As we see, we enter what is called an infinite loop. So when you lose control of an iterative statement, it goes on to repeat itself till you decide to terminate the program itself. So that is called an infinite loop. So for example, over here, for the condition, let's see what happens if I give it as 0. So what happens is, when it comes to check the condition for executing the loop, what it finds is 0, and 0 is the equivalent to Boolean of false. So it sees that the condition itself is false, and it does not proceed with executing the block of statements. So that was just one of the many quirks of each of these iterative statements. Feel free to play around with them. Next, let's see how do we next we'll move on to what while loops are and how we can achieve similar functionality of printing first n natural numbers using it. So the similar solution for that problem for using a while loop would look something like this. The syntax for a while loop is much more simpler than that of for, in which there is while keyword and there's a condition, and depending on the condition, we execute a block of statements. Quite simple. So how we can relate these two is, we can break down a for loop into a while loop by separating the initialization and the modification or updation statements. So as we can see, while loop only has the conditional statement over here, which is used to check whether or not the block of code should be repeated. And what we do is we make an initialization before execute I mean before the while keyword, or before defining the while loop construct. And within the loop itself, we try to increment the value which we use to control the loop with. So now let's see how this behaves as well. Print using while. So we see that we are still able to print 1000 numbers as they are. Now, since it is not as restrictive as for loop, in the sense that it does not actually need such three statements, etc., you can play around much more with loop, with while loop over here. And so let's try and observe how the break and continue statements actually work. What happens if I remove this condition over here and I make it true? So as discussed before, what will happen in this case, since the condition is always true, it will keep on executing these statements, and that is called a infinite loop. What we can do here is, let's say I want to execute, or I want to print I only till 100. So if I is greater than or equal to 100, what I do is, I do not want it to print anymore, break. So now what this will do is, let's try and follow the controller to understand what will happen actually. So int I equal to 1, i's value is 1. It comes to the loop, it checks the condition is true. It will come over here. Is I greater than or equal to 100? No, because I is 1. So it'll print out I, it'll increment I, it'll go back again, check the condition in the while statement. The condition is true. It'll again check if I is greater than or equal to 100. It'll print I, it'll increment I, so on. It'll go on till i's value is greater than or equal to 100. When i's value reaches 100, it'll perform the code which is within the if brackets, which is and the line of code within them, within those two brackets, is break. So when the code will encounter this break statement, what it will do is, it will come out of these this code block between the lines 44 and 50. Between these pink braces, the controller will come out of it entirely. And if I have another statement called cout out of the loop, then what will happen is, it'll go on printing I till the value is actually 99, and once it reaches 100, it'll break, and then it'll print out of the loop. Now what is continue then? So let's take an example. Instead of printing the first n natural numbers, what I want to do is, let's print only the first odd numbers. Okay, so let's print like 10 odd numbers, or all the odd numbers before 100. How would we do that? So in natural numbers, if we ignore the even numbers, we get odd numbers, right? So one of the ways to reach that solution would be that if I mod 2 double equal to 0, which is if I is divisible by 2, what we do is, we do a continue. So what we are essentially doing here is, once we enter the loop, if I is less than 100, we check if I is divisible by 2. If I is divisible by 2, I do not want to print the value again. What I do is, I continue on to the next loop. Although this won't exactly work, because I'll have to make changes to I as well anyway. I plus plus and continue. Or rather, let's see. Right, so I'm starting with 0, I increment I check if I is greater than or equal to 100. It is not. If it is not, then what it'll do is, it will check if I is even. If I is even, it will continue, it will increment the value of I again, and then it will check here, is I still divisible by 2? No, because after an even, we'll have an odd number, which will not be satisfied So the continue statement will never be encountered and we'll be able to print I. So as you can see, if break is encountered, it will come out of this entire looping block. But when continue is encountered, any line of code within this entire looping block after the continue statement will never be executed. The controller will shift directly from line number 50 and will go back to 44, wherein it will check the condition again. So now let's see the code in action. Right. So what did we observe? It prints 1. When it comes to 2, we'll see that 2 is divisible by 2, of course. So it will encounter the continue statement and hence it will never actually come and execute the cout I where we are printing the value of I to our console. So for 2, it will skip. It will go to the next iteration. It will increment the value of I. And then I will not be even anymore. So this condition will fail. We never actually encounter the continue statement in that case. And we go on to print the odd value of I. Next, so this was about 2 of the loop control statements, break and continue, which you will be using for most of the time. Next, let's move on to the print using do while loop. Okay, so basically the do while loop. So this is the syntax of the do while loop. The do keyword in the block of statements, after which we use the while keyword and the condition. So one of the things which you may notice is we are actually executing the block of statements and then checking the condition. So one of the properties of do while statements as visible is that irrespective of the condition, at least once these block of statements will be executed. Also, do note in the syntax that after we've written the condition, there is a semicolon. So do remember that when you're trying to write the code on your own. So coming back to our original problem, wherein we want to print the first 10 natural numbers, how will we do that? Using do while loop. So I initialize a value I, which I'll use to keep track in my loop. I print the value of 5 after I've entered the do while loop. I increment the value of 5 then and there. And then I check the value, then I check the condition, similar to how I did in while loop. So there may be certain cases wherein you want to actually execute whatever block of code is there at least once. And then depending upon further conditions, we decide if we want to do it again or we decide to skip it. That is basically the use of do while loop. Let's just see it in action. Print using do while. So again, number still 1000 are printed. Now let's again, what happens like if you're playing around with code, and what happens, how will you deal if you actually come across an infinite loop? So one of the ways to make sure that you don't actually go in an infinite loop is to have a condition specifying that maybe if it is like if I is greater than 10,000 or something, then break. So break is one of the keywords which you can always use to get out of the loop. But what if your logic itself is wrong? What if the logic you've written leads to an infinite loop irrespectively? How do you shut it down in the terminal so that you don't panic or your system doesn't freeze up, etc.? So one of the very neat little ways to do it is, so let's say I'm calling this function called infinite loop, which will go on printing DevTown infinite number of times. So here we see that DevTown is being continuously printed and I can't actually go ahead and use my terminal anymore. One of the ways you actually break that infinite loop is by using Control C, which will kill the program and it will help you come out of the infinite loop. So this is just for you so that when you're testing out, in case ever you write a code which leads to an infinite loop, you're able to handle it. So this was all about iterative statements and loops in C++. Thank you.